now we're going to find the percent composition. Let's do K2 SO4. So basically when you have these subscripts, you have to add those into account. You have to take those into account. So we got potassium sulfate, looks like. Obviously, you can tell that the 2 came from the sulfate. The 4 was already with sulfate. It's SO4, 2 minus. It's a compound already. Usually when there's 3 elements, one of them was already a compound. Usually it's the last one. But in the case where you asked me about the ammonium chromate, which is the NH4,2Cr2O7, that is 2 compounds, as you can tell, because there's more than 2 elements or 3 elements, which means that 2 of them are compounds. If there's 4 elements, that means 2 of them are compounds, but that shouldn't really matter because you should be able to look that up and just be able to determine that by easy eye. Alright, so we got K2SO4. So basically the whole thing about percent composition is you take whatever element you're trying to find. So you have 3, determine how many, first of all, this is what you need to do. Determine how many elements are in the compound that you have. So we got potassium, we got sulfur, and we got oxygen, right? Now you also have to take into account how many of those elements you have. So you obviously have 2 potassiums and you have only 1 sulfur because there's no subscript there. So we use that as 1, and we have 4 oxygens. So we have to take that into account. So now when you find the percent composition, you take whatever that element is. So you take the molar mass. So let's just talk about it real quick. Let's say let's do the potassium one. So you get the molar mass of potassium, which is 39.10. Now, you know that you have 2 of that, right? You have 2 of those. So you're going to multiply that by 2, which will give you 39.10 times 2, which will give you 78.2, correct? Alright, so you're going to put that above the whole molar mass of the whole compound. So then next you have to find the whole molar mass of the whole compound. So you have to add all of the molar masses together. So let's do that right now. So we already know K2, which is 78.2 plus sulfur, which is 32.06, plus 4 O's, which is each of them are 16, and you get a whole molar mass. This is the molar mass, okay? So grams, molar mass of the whole compound, So we're going to take that number and we're going to use that number for each percent composition that we're trying to find, all right? So what you have to do, so let's do potassium first. I suggest you write the element on the side so you kind of know which one you're kind of doing. So we're going to take the molar mass of potassium, which is 39.10, and we're going to multiply that by 2, because we have 2 of those. And then we're going to divide that by 174.26 grams. They're both grams, because, they're both molar masses. So, you have 78.2 if you want to do that. I mean, you don't have to do the extra step if you don't want to, but you're going to get a whole thing about, you're going to get 0.448. You have to multiply that by 100 because you're finding the percent. This is a decimal, and when you have a decimal, to make it a percent, you move it over to the right 2 spaces, or you can multiply it by 100 if you don't feel comfortable by doing that. So you're just going to get 44.8% composition of K. Okay? Alright. So now for S. Let's not do orange, let's do green. Alright, so for S. Now you only have one S, so you don't have to take into account, you don't have to multiply its molar mass by a number, because you only have one. 32.06 but I'm going to put 1 in parentheses just so you know that you don't have, that's the thing. This is, here, let me write it, subscript. It's the subscript of each one, okay? So then you're going to take the molar mass of the whole compound, obviously, again, because that's what you're using to find the percent composition. You're basically finding, like if you had a pizza and you're finding out how much of the pizza was eaten. Obviously, you can see 1/4 was, so what's the percent of the pizza that was eaten? 25% of the pizza was eaten. Okay, so like basically that's what you're finding. You're finding how much of the compound, how much of that element is taking up the compound. So we obviously found out that potassium is taking up 44.8% of the compound. That's basically almost half the compound. So we now know that the other ones will probably be less. So 32.06 divided by 74.2, which is going, oh, whoops, it's 26, sorry. I mean, it's not going to make much of a difference, but on your test, make sure that you don't round until the last time. I'm sure he probably told you that, but like legit, don't round until you're all said and done. So you're going to get 18.4%. See, as you can tell, I was able to determine that the other ones are going to be significantly less because you already have 45% basically already used up. So the other ones are going to be less. Alright, what one do we have done? Let's do red, I don't care. Alright, so we're going to go on O. This is going to be not as big as K, but it's going to be a pretty big one. Alright. So the molar mass of O is 16, and you have 4 of those. So you have to take that into account. Then you have to divide that by the whole molar mass of the compound. Know that, the whole molar mass of the compound. That's the first thing that you should actually find, because then you'll know, just find the molar mass of the other ones, times it by the subscript, put that over the molar mass of the whole compound, because you wouldn't divide the molar mass of the whole compound by a little number. That makes absolutely no sense. Yeah. So basically you're going to get 16 times 4, which is 64, divided by 174.26, which gives you 0.367 times 100, which gives you 36.7%. And to check your answer, you can add all of these up and see if they equal about 100. And obviously, some of them we rounded. Obviously, it was like 18.39, I believe. We rounded it to 18.4. So obviously, it may not come out to be a straight 100, but it will come really, really close to 100 because you rounded. So you could just take the beginning numbers, like 44, 18, 36, and if it rounds up to about 100, then it should be good. That's how you check to make sure you did it right.